All right, good morning. Today we're going to be talking more about energy. Shocking, I know. But we're going to be looking at how energy waves interact with mediums or matter. And there are four different ways. However, we're only going to focus on the first two today, which are reflection and refraction. And you'll see that you have two different notebook entries. So this is just part one of wave interactions, and you've got reflection on one page and refraction on the other. So right now we're going to focus in on reflection. All right, so focusing in, we want to look at this kind of like the definition or description of what a reflection is. So when an energy wave is traveling towards a new medium, and one that it cannot travel through, or at least some of the wave cannot travel through, it will end up bouncing back. So don't worry about drawing the diagrams right now. We're going to do that together in just a second, making sure we understand all the vocabulary that is integrated with the drawing. But I want you to fill in that top sentence. It says reflection is when an energy wave reaches a medium that it cannot travel through and therefore bounces back. So that's just kind of the definition of reflection. Now, before we get into drawing, like I said, we're going to go through step by step kind of what happens. So you notice that on the drawings before, and we're going to kind of flip back and forth, but on the drawings before, there was an incoming wave, or it's also known as the incident wave. And just a side note, wave can sometimes be called a ray. So we have an incoming wave, or an incident wave, or an incoming ray, or an incident ray, all the same meaning. But basically it is the energy wave that is moving towards a boundary or a barrier medium. So here on this girl, she has her sunglasses on. So this is a barrier medium to some of the sunlight that is shining towards her. So we have this incoming wave. It can also be called an incident wave. And we can see here right in the corner, there is an arrow showing that that energy wave is going towards her sunglasses. So that's how we know it's the incoming wave. Now, the second thing that you need to know is that the part of the energy wave that bounces back because it cannot go through the barrier medium is called the reflective wave. And in the diagram here, you can see the energy wave hits the sunglasses and is reflected back out, and this is the reflected wave. It can be the reflected ray. That's pretty much it, just those two. Now, the third thing that you need to know is that the angle that the incoming wave forms when it bounces onto that barrier surface is called the angle of incidence. Let's look at where this is in the diagram. So we have the angle of incidence. Notice that there's this normal line right here, okay? The normal represents a 90-degree area to the barrier medium here. So this is a 90-degree angle here. And so basically, if a wave was coming in directly on the normal line, what would happen is it would bounce back and go right back out on the normal line. However, you can see that this incoming wave is coming into the barrier medium of her sunglasses, and it's going to bounce off this direction because it's not coming in on the normal line. This angle that is between the normal and the incoming wave, or the incident wave, is called the angle of incidence. Now, the next thing that you need to know is the angle of reflection. The angle of reflection is located directly between the normal line and the angle of the wave of reflection. So right here between the normal and the reflected wave is called the angle of reflection. All right. Something very important to note, and we've already talked about the normal, so I'm going to kind of go on, but is the law of reflection. And so there's not really an area to write this on your notes, but you might want to squeeze it in at the very bottom under the real life application bullet point. Is that the angle of incidence is always equal to the angle of reflection. So if we look here, in this beginning diagram, let's look at this one for a second, okay? We have a mirror here. We have light coming into the mirror, so we have the incident ray. We have the reflected ray, which actually should have an arrow over here. That means that this is the normal, because this would be perpendicular to the mirror surface. And we have an angle of incidence here and the angle of reflection. These two are equal. And I'm going to show you what you can do in your own diagrams when you're trying to show that you're following the law of reflection and showing that the angle of incidence is equal to the angle of reflection. So before we move on, we are going to take a minute to draw the diagram and include all the labels that you need to include on your diagrams in the future, as well as just remind you what the meanings are. So we're going to just draw the barrier medium first. So this is the medium that a certain wave cannot enter. And so we're going to write below this barrier medium. So you are drawing this as I am drawing it with you. Next, the next important thing you want to draw on your diagram, and this isn't going to be perfect right now because we're not using any measuring tools, we're just kind of drawing a simple diagram, is you're going to draw what is representing a normal to the barrier medium. And this is a 90-degree angle. So I'm going to go ahead and do this symbol, which means that this normal line is perpendicular to the barrier medium. So I'm going to label this normal. The next thing you want to do is have an incoming energy wave, or what's called an incident wave. Now I'm just going to kind of mix things up a little bit, and I'm going to draw the incoming wave coming in this direction, because what says that it can't come in? And it's going to be hitting right at where the normal and the barrier medium meet. And I'm going to call this incident, use that full science vocabulary term, incident wave. Okay, so here I have my arrow showing that that is the energy coming in to the barrier medium. And the next thing we want to draw is the incident angle right here. Now, I'm not going to take time to measure this, but what I'm going to say is I'm going to put one little tick mark showing that that is a certain value angle, certain degree of angle. And what I'm going to do is I'm going to reflect that incident wave off, trying to go at the same angle. And so I'm going to write reflected or reflective wave. Make sure that you do include that arrow showing the direction of the energy being propagated through. Okay. And then I want to include my reflective angle, which I'm going to put the same number of tick marks. I put one over here, I put one over there. That indicates that these two angles are equal. So again, this is called the angle of incidence because it's between the incident wave and the normal line. And this is called the angle of reflection. Okay. All right, kind of sloppy, but you can see the point. Hopefully you have something similar on your paper and that it's understandable for you. All right, so filling in the last blank on your reflection page is the real life application. And we've already talked about a couple, so kind of jog your memory and think about what are some instances in life where energy waves would be reflected. Well, one is we talked about sunglasses. That's why we wear sunglasses, to protect our eyes from all of that sunlight energy getting into our eyes and damaging them. We also talked about mirrors. The way you can see yourself in a mirror is light reflecting off of them, which reflects your image. Okay. And then another one is pool. People who play professional billiards or pool use reflection quite a bit to study the angles that the ball will hit. and the way it will travel after that. So those are just 3 real life applications how reflection appears in our daily lives. Now we're going to move on to refraction. Refraction is when an energy wave enters a different medium that it can travel through. Okay, so that it can travel through. And therefore, what happens is it actually bends. So the wave will not continue in the same angle, but it'll bend. And that is due to part of the energy wave changing speed. Again, don't worry about drawing this diagram. We're going to fix it up later. It's something that we can do in just a second. But I want to talk to you about why, a little bit more in depth, so you understand why does the energy wave bend when it is moving into a new medium. And it has to do with part of the wave slows down before the rest of it slows down. And I want you to think about driving. Kind of scary. You'll be driving in 3 or 4 years, right? But when you're driving, if you hit a really rough patch, like say like sand or real soft dirt with one tire, what's going to happen to your car? Well, it's going to be pulled to the direction where that tire is going through that rough area of land. And the reason why is because your car is moving at the same speed, but then all of a sudden one tire gets slowed down and the car gets pulled or bent in that direction. So 2 of your tires are going to be closer to the inside of that curve, and 2 of your tires will be in the outside of that curve. So that's kind of how energy waves bend as they enter a new medium. Some everyday examples. So I am going to skip right now to beneath the drawing, which we'll come back and do in just a second. But everyday examples of refraction are rainbows. And we're going to talk more in depth about this in just a second. But another is anytime that you have something in water, like a straw or maybe a pencil or something like that, it looks like that the object is bent or that it changes shape underwater, and that is due to refraction. Light is traveling through gas and it enters the new medium of water, and it's going to slow down or bend, and therefore it changes our view of the object. All right, so we're going to talk right now and fill in the very bottom diagram where it says draw a diagram showing why light creates a rainbow when it refracts through water. So what I want you to do is draw an arrow representing white light. So draw an arrow and label it white light. Now instead of this prism, I would like you to draw like a teardrop and label it water in the atmosphere. So what we have is the sunlight, which represents the white light, and it's traveling through empty space, and it's traveling through most of our atmosphere where water is not present. However, then it enters the troposphere where there's more water vapor in the atmosphere there, and that's a different medium, and the light gets bent. Now, I don't know if you knew this or not, but white light is comprised of all colors of the rainbow. So when this energy, light energy, enters into the new medium of water vapor in the atmosphere, it gets bent. And the red light bends the least, and the blue light bends the most. So that's how rainbows form. So make sure that in your diagram you have an extension of a line where maybe you label R, O, Y, G, B, and V, showing how red light bends the least. So it'd be located at the top of the bend, and at the very bottom of the bend where the light bends a lot, it would say blue light or violet light. All right, so we don't have a lot of time left on this video, so try to stick with me. If you have to pause it, go ahead. But I'm gonna draw a line here, and I'm gonna write M1 for medium 1, and I'm gonna write down here M2 for the second medium. And then I'm gonna draw this dotted line that represents, you got it, the normal, because it's perpendicular to my medium boundaries. And so then I have an energy wave coming in. This could be light or some kind of energy wave, and I'm showing the way it's traveling. You want to label this incident wave, and I'm going to abbreviate right now just for the lack of time. when it goes through